Our next problem is a system of nonlinear equations. The first equation, if you remember all the way back to the beginning of the semester, is the equation of a circle with radius square root of 13. The second equation is the equation of a parabola. So we want to find the point of intersection of a circle with a parabola. Now, a couple things could happen. You have a circle and a parabola. It's possible that the circle and parabola don't touch at all, or maybe they touch exactly once, or maybe they touch twice, or maybe they touch 3 times, or it's possible that they could touch 4 times. So I don't really care about graphing this since there are so many possibilities, and getting a accurate enough sketch won't give us exact answers. I'm just going to solve this the way I did the last one, trying to match up the terms and eliminate something. So rewriting it with our terms, we've got x squared terms, y squared terms, y terms, and numbers. In our first one, we have x squareds, y squareds, and numbers. Our second one, we have x squareds, y's, and numbers. So if we look at that and we think we want to do some eliminating, if we multiply the second one by a -1, we'll be able to eliminate the x squareds. You know, that would be the same thing as saying, hey, let's just subtract these two lines. It's the same as multiplying the second by a -1 and then adding them. So the x's cancel out. I've got a y squared. Don't forget, now we have a positive y. And if we have a -7 here, 13 minus 7 is 6. So I'm hoping that we can solve this. We can find the y's that work for this. Let's subtract the 6 over to the other side. And this looks like it's going to factor. Y plus 3, y minus 2. Which means, in order for this to equal 0, y is either -3 or +2. If y is -3, we need to think about substituting back into either equation 1 or equation 2. Doesn't matter which one we substitute back into. If we substitute back, we can do x squared plus 3, because that's minus negative, is equal to 7. Subtract over the 3, take the square root of both sides, and we get 2 solutions here. X is +2, y is -3, x is -2, y is -3. Then, if y is 2, substituting back into the equation, x squared minus y equals 7. Adding over 2 to both sides, take the square root. Don't forget plus or minus. That means we've got when x is +3, y is 2. When x is -3, y is 2. So it looks like we've got four solutions, and that last option was our option that we wanted. So our 4 solutions are the 4 points where this intersects, the circle intersects with the parabola.